In this video, we will be learning about section 11.3, which is all about the properties of liquids. We have already seen how intermolecular forces can affect the properties of substances. Remember that these can be London dispersion forces, dipole-dipole interactions, hydrogen bonding, ion-dipole attractions, and ionic bonding. For example, water is such a unique liquid because of its hydrogen bonds, which are the result of especially strong dipole-dipole intermolecular forces between the hydrogen and oxygen.
The first property that liquids exhibit is cohesion. Cohesion is the attraction between similar molecules, and it is caused by intermolecular forces. An application of cohesion can be seen in surface tension. Surface tension, as you may remember from last year, pertains to the stronger attractive forces between molecules at the surface of the liquid. It is a result of cohesive forces. In liquids, molecules cohere to other molecules on all sides except for the ones at the surface. Therefore, the molecules at the surface demonstrate stronger cohesive forces between them. The surface molecules become more tightly packed, resulting in the formation of surface tension. This is what allows water striders to walk across water. In this demonstration, we show how a paperclip is able to float on water due to its strong surface tension, even though the paperclip is more dense. The especially strong cohesive forces form a kind of skin at the surface, and the paperclip does not have enough force to break the skin. In the particular case of water, hydrogen bonds between the oxygen and hydrogen are what cause the cohesive forces. The paperclip is floating right now, but look at what happens when we add a few drops of dish soap to the water. The paperclip sinks because the dish soap binds with the water molecules, interfering with the hydrogen bonds and cohesive forces, which ultimately disrupt the surface tension.
Another result of intermolecular forces in liquids is adhesion. Adhesion is the attraction between two different substances. One example of this is how water is attracted to glass. Glass is made of a covalent network structure of silicon dioxide. Oxygen has a much higher electronegativity than silicon, so it has a more partially negative charge, attracting to the partially positive hydrogen atoms in the water. Similarly, silicon has a partially positive charge, so it is attracted to the partially negative oxygen in water. Capillary action is a phenomenon that only occurs in liquids that have greater adhesive forces than cohesive forces. The adhesive forces between the liquid and the walls of its vessel will cause the liquid to curl up the sides of the vessel. Then, due to cohesive forces, the liquid molecules will pull each other up. This allows the liquid to curl up the sides of surfaces, and this is how water travels up in a tree. This demonstration clearly portrays the effects of capillary action on water. Water is a great example for capillary action because of its strong hydrogen bonds and high polarity. One beaker contains water with blue food coloring, while another beaker contains water with light green food coloring. A paper towel is placed in each of these beakers. One side is submerged in the water, while the other side is placed over an empty beaker. Due to capillary action, the water from each beaker will travel through the paper towel and into the empty beaker. The blue and light green food coloring will combine to produce a darker green color.
The meniscus of a liquid is its curvature at the surface within a container. For example, we have always learned to measure from the bottom of the meniscus in labs. Concave meniscuses are formed when the adhesive forces are greater than the cohesive forces. The liquid molecules are more attracted to the sides of the vessels, which is why the meniscus curves up towards the sides. An example of this is water. Convex meniscuses are the opposite. They are formed when the cohesive forces are greater than the adhesive forces, causing the meniscus to curve down towards the sides. An example of this is mercury.
Viscosity pertains to the resistance of a liquid to flow. Stronger intermolecular forces makes it harder for molecules to move past each other, so viscosity increases along with stronger intermolecular forces. Viscosity also decreases with higher temperatures. This should make sense because higher temperatures increase the kinetic energy, which makes it easier for molecules to move past each other. Take a look at this contrast in viscosity. If you were to pour a glass of water and a glass of honey at the same time, for example, the honey would pour out much slower because of its higher viscosity.
So in this video, we learned all about the different properties of liquids. Let's summarize all of them. Cohesion is the attraction between like molecules due to intermolecular forces, and these cohesive forces become stronger at the surface of a liquid, creating surface tension. Adhesion is the attraction between different molecules, also due to intermolecular forces, and cohesion and adhesion work together in a process called capillary action, in which a liquid is able to crawl up the sides of a vessel. Meniscuses, or the curvature of liquids at the surface, are either concave or convex, depending on whether the cohesive or adhesive forces are greater. Finally, viscosity is the resistance to flow that a liquid experiences. Remember that these forces are all the result of intermolecular forces. This wraps up section 11.3. Thanks for watching.